Good morning. I'm going to talk about the evolution and the future of the network itself. AT&T has been involved in things like virtualization, SDN, API enablement, data models, all of these new technologies that have made networking so exciting during the last decade. We have been on the forefront of all of that. I think there is a big missing piece, which is the network itself is monolithic. We haven't harvested the power of what I call modular architecture for the network itself. So I think that's really what needs to change in order to really make networking even more exciting over the next decade. So that's the main topic of what I want to talk about. And this is kind of a new journey. The web-scale data centers have done some of this. But the web-scale data centers are much simpler compared to the global WAN that the service providers have to run. And so far, we have been kind of saying, well, we can't run open source software in our routers and ROADMs. And that's, I believe, have to change and about to change. So let me start with a few key trends that has gotten us here and taking us forward. So I want to touch on three areas. Speed, that's nothing new. I think it was 9.6 kilobits per second when I entered the industry. That feels like long, long time ago. Now we are dealing with 100 gig backbones. I'm pretty sure all the operators here in the room probably have 100 gig backbones. Customers are buying 100 gig access. That's all great. And we are moving to 400 gig. We actually demonstrated a 400 gig capability earlier this year with a few key vendor partners. And I believe in the next 1 to 2 years, 400 gig will become the core of the backbone. And 1T is probably not far away. Access, 5G. I don't have to really tell you about it. We have all heard about the promise and power of 5G, how it's going to transform the mobile network and the RAN. The third dimension of speed is switching. The merchant silicon capability, which is key to modularization of the network, which I'll get to shortly. We can buy a 6400 gig port fixed form factor router using merchant silicon hardware today. That's amazing. And that's set to double in the next cycle. So these are three major speed increase dimensions which are driving the industry. Even more exciting is the architecture. Like I said earlier, things like SDN, virtualization, APIs, and all of that have revolutionized the architecture. Now, two big things which are going to enable modular architecture is off-the-shelf hardware. Again, in the service provider networks, we don't really use that. Open software. I think ARPIT talks about open source. That's a component of modular architecture. Now, cloud applications moving to the cloud has been a big trend. That's about to become much more interesting with edge compute. So it's an opportunity for the service providers to have edge compute capability, hundreds, possibly thousands of edge compute locations, and the power of what we can unleash in terms of low latency computing and all the different things we can deliver with that. That's an exciting future in the architecture arena. Last but least, big data and AI and machine learning and all of these new technologies. Really what it's doing is it's creating a higher level of abstraction, right? Things like SDN provided as a level of abstraction for the network. That's making it even a higher level of abstraction. That's what folks sometimes refer to as intent-based networking. So, all I need to do is, speak a word, and the network will take care of it itself. So it's not far-fetched. It's all about abstraction and ability to bring together modular components together. So third, services. I think a lot of the speakers talked about all the innovations in services. My colleague Josh Goodell talked about it yesterday during his opening keynote. Services are software-defined, on-demand, real-time. In fact, if they are not, they are kind of stuck in the past. SD-WAN is the big new service. MPLS VPN is 20 years old. It was 1997 when we first demonstrated MPLS VPN. It wasn't even called MPLS at that time. It's amazing that something like that lasted for 20 years. It's about time that something like SD-WAN, by the way, it's not going to kill MPLS, unlike some of the hype we hear. It's just going to improve what we created 20 years ago with MPLS VPN, providing visibility and application visibility and all of the other things SD-WAN does without having to deploy probes and all the expensive things. It's built into the network. So combined, collectively, this represents an exciting next decade for the network. So let me go to the topic of modular architecture and open and modular architecture. So today, we deploy monolithic elements in the network. So primarily, if you look at two major layers of the network, the optical layer and the packet layer, both layers have these monolithic elements. Things like DWDMs and ROADMs in the optical layer, and routers in the packet layer. So the key property is hardware and software are tightly coupled. And we procure them from the same vendor. And in the optical arena, not only that we procure them from the same vendor, we deploy a single vendor's technology in a geography. So a vendor has geographic exclusivity. That's not modular architecture. So routers are interoperable, but again, hardware and software is coupled, and we buy the whole monolithic system from a single vendor. So this is what is about to change. So what I'm showing the picture on the right is it's really a way of decoupling this. The hardware itself becomes componentized, software is decoupled, and we have open interfaces and data models that enable all of these things to become plug and play. And this happened in the computer industry with Linux and its predecessors like Unix over the last 20, 30 years. Networking has been kind of resisting this, and it's about to change. Now, we at AT&T have embarked on certain areas already. And I'll talk about optical in a moment, but we have a service called FluxWare. We use something called universal CPE. It is a white box CPE router. We figured we'll start with what's at the customer prom. That's where we felt it was the most powerful. It's already disaggregated, and we use white box hardware and disaggregated software. We are about to move that concept into the core of the network. So that's really what I want to go through next. So in the optical layer, this means ROADMs become open ROADMs, so they can interoperate. Under the packet layer, routers become disaggregated routers so that I don't have to procure the box from a single OEM. I can buy hardware from your favorite ODM directly, and I can run my own software, or I can license software from your favorite software vendor. And you can mix and match components to make the whole software stack. And again, this doesn't really exist in service provider networks today. It does exist to some degree in the web scale. And so we know that it actually works. We just had to take it to the service provider environment to really realize this. So, if anybody has any doubt, why do this? What's wrong with the monolithic systems that we have deployed for decades? I think the reasons are pretty obvious. I don't think I need to go through it in any kind of depth. It's certainly a lot less costly. All you need to do is compare a cost of a 100 gig port on your favorite OEM vendor's router, compare it to what it could be on that 6400 gig port fixed form factor white box that I talked about. I think you'll find it 10 to 30x kind of difference. Cycle time. I don't have to wait for 18 months for my OEM to develop a small little feature that's important to me, but maybe not all that important to that vendor's global priority. Disaggregated software will enable me to write my own code and plug that in, or I can have somebody else do it for me and integrate that. Innovation, again, new features can be added a lot faster, and the user has control on what to innovate, what's important to the user's requirements. It's more interoperable, and I'll talk about the optical layer in a moment. And it's easier to optimize the network. The SDN control and all of that will become a lot more effective with disaggregated systems. So on the optical layer, AT&T announced this a year ago. We helped create this community called openrodem.org, which has been functional for over a year. And the openrodem.org has published a set of standards. And what it really translates to is the monolithic ROADM now gets disaggregated. So you have pluggable optics, transponders, and the ROADM itself. They become components. And they can be assembled and procured and deployed separately. So I can have one vendor's ROADM interoperate with another vendor, which in this arena was not possible in the past. So common interfaces, common data models, these have all been standardized, and several vendors have already built components with which we can build systems. There's also a SDN controller and APIs to that, driven by ODL specifications. So this is a complete system that we can really deploy, and we do plan to deploy this in 2018 in production mode. We demonstrated this earlier this year, but we're going to deploy it in production mode starting next year. Much more, it has all the properties of what I talked about earlier, why disaggregate plus is lower cost. So those are the motivations why we're doing this. Now the packet layer, this is the router, this is the carrier router, core router, edge router, that kind of stuff. I already talked about, we have done disaggregation of CPE routers already. That's already happening. But when it comes to core and edge routers, people are kind of afraid to touch it. And what I tell our own folks is, routers have to behave like servers, right? So that's one way to think about, people are afraid to disaggregate. That was the case with mainframe computers 30 years ago. And, servers allow you agility. I can add components and software at will. I don't need to have 8-hour maintenance windows just to move a customer from one port to another port. All of that has to change. And that's what disaggregation of router will allow us to do. So we have defined an approach, an architecture, if you may, which is kind of 4 layers. So think of these as piece parts that get disaggregated. Of course, there's hardware at the bottom. So with the white box hardware, that's already available. So that's already something that you can do. The harder part is the software. So today, I think from what I understand, most of the carrier router vendors are starting to sell disaggregated software. So which means I can buy software alone, software only, from my OEM vendor, run it on white box hardware that I procure. I think we have pretty much reached that stage. It's just starting to happen. It's probably unthinkable even as recently as 2 years ago. But that's not enough. We want to take it to another step, which is the software itself needs to become modularized and disaggregated so that an ecosystem, a component ecosystem, can be made. So that's what I'm showing here, which is, so you need a forwarding abstraction layer so that you can plug in silicon easily without having to go through complex development. You need a shared data layer. You know, Linux kernel or whatever is the convenient place, all the routing information base and all other databases that need to be maintained needs to be standardized, because today they are all closed. There are no standards for all of that. They all need to be standardized and opened up so that applications can talk to those things using open APIs and open interfaces. So what are these applications? These are routing protocols, management systems, management protocols, and some of these things the service provider themselves may be able to develop them, or end user may be able to develop it. Or I can buy it from a specialist software provider and plug that into the disaggregated system. So this is the vision that we are painting. We believe that this is achievable. Like I said, proof is already there in the web scale data center. It's just a question of us doing this. And so let's make the big routers, make them look like servers so that our operations organizations can adapt to that. So that's really the main thing I want to talk about, but I didn't want to end my talk without giving a little bit of kudos and reference to the inter-provider API work. I know a couple of speakers referred to this already, so this is not new. And if you haven't seen the demo downstairs, please don't leave without seeing this. So we got together, in fact, AT&T, Colt, and Orange were the three service providers who got together and worked with, and we got great support from MEF. The LSO framework was already there, so that was very convenient. So when ONAP became available, so a bunch of things kind of came together over the last year, which enabled us to create this inter-carrier API. So the way I talk to my team about this is, we're kind of making carrier Ethernet behave like the intranet, right? In intranet, I don't worry about my customer's address in the UK if I have to deliver service there. All I need to know is the URL. So it's kind of like that. You know, I can sit here in the US and say, I have a customer in the UK, I want to turn up service. Why can't I do that? Well, that's partly business model, partly technology, so we can change that with this. That's the way, you know, I think about, you know, this initiative. So this is a set of standards and a reference framework, and it's actually been developed and demonstrated. I think you already saw this picture. You know, we have these two layers of APIs, Sonata, that allows the business systems to communicate. So you can place orders, you can send bills, you can open tickets, all of that in real time. So like I said, sitting here, I can, you know, inquire whether service is available in a particular street in the UK and, you know, send an order to Colt, and voila, you know, service can be activated. Interlude is a network API that allows elastic capabilities, so things like I turned up service, but I don't have enough bandwidth provisioned. The traffic is a lot higher in quantity than what has been provisioned. Rather than waiting for, you know, change orders and MACDs and things like that, why can't the system automatically adapt? That's what, you know, we are demonstrating, you know, downstairs. So like I said, this is working demo, and I think I'm pretty sure all service providers are thinking about the strategies on how do we deploy this. So that'll be a really good outcome for the Ethernet industry. So just to wrap up, I just want to say congratulations to the 20+ companies who collaborated to make this happen, especially, you know, our partners from Colt and Orange, who did a lot of work with us. The V1 release of the Sonata APIs have already been released earlier this year, and it has an extensible data model, and other APIs are under development. So that's really all I had, and I want to thank MEF for inviting me, and thank you.